the module 2 and 3 went smoothly and you were able to upload your assignment. I'm gonna read over them in the next couple days, probably by Friday. I'll put up my feedback. So you can look towards that, but you don't have to wait for my feedback to like get your CEUs and all of that. So once you've finished this, then I think they send you a survey, you fill that out, and then you should get your CEUs pretty quickly after that, if any of you need that. All right, so let's
Right, what's the
oh,
CEU?
what's that?
What's the CEU or
CEU is like continuing education units or something. Some schools require you to have a certain amount. Or even if your school doesn't require you to have the certain amount, but like you needed to prove that you did this to your school or something, like if they paid for it and you have to prove that you actually did it, you should get like this thing in the mail for that.
Okay.
Okay. Sorry, I'm just making sure no one, okay, good, is trying to get in through email. Okay, so I have a lot of stuff today, and then I have my Google Drive with everything that I have from my or a lot. It's probably not everything, but it's a lot of stuff, and it could be overwhelming. So I will give that to everyone. I'll put it in the link in the end. I don't want to give it to you now because then you won't listen to a word I say for 2 hours. You'll just be going through the Google Drive. So hopefully we can chat together about this stuff here. So I'm going to share and get started on this. I can't see everyone, so if you have a question, feel free to interrupt if I'm going too fast, but I'll go back and forth when I can. All right, so today is module 4. This is your last module for this, and I just wanted to give you an overview of what we're going to talk about. And again, my name is Kim, and I'm at Newtown High School in Connecticut. So this is what my ideas for tonight, and feel free to stop anytime you have questions. We're going to talk about inquiry lab activities, then graphing things that I do. We'll talk about energy diagrams, which some people call the LOL diagrams. We'll spend some time doing linearization labs. Sorry, letting someone in. We'll talk a little bit about fluids, just in case anyone's nervous that fluids is now on the AP1 exam. We'll look at Tipper's ranking tasks, which I use a lot, and then I have a list of inexpensive labs that I do / online labs if budget concerns or something that your school has. And all of the links and everything that I'm going to show tonight will be in that Google Drive. So you will have access to everything that we do tonight. If for some reason something is not there, you're feel free to email me at, anytime throughout the year. I'm happy to email you back and help you, or if you're struggling. So don't forget that just because tonight ends, you can't ever talk to me again. All right, so we're going to do some talking about inquiry labs. Just wanted to do a quick review of the levels of inquiry. So we have confirmation, structured, guided, and open. So confirmation is kind of like that cookie cutter one where you even make their data table for them. You want to try to stay away from that, but sometimes you will do that, especially if you're doing like a linearization type thing. And then we have structured, where I would give them a question and then they design the procedure. Then we have the guided and then open. I would say I mostly live in the structured to guided area. I find with AP1 there is a lot to do, so I don't really have a lot of time for open-ended ones. And then most of the time I stay away from confirmation. So trying to make them come up with a procedure is really important because they will also get assessed on that on the AP exam. All right, so this is all stuff you probably already know, so make sure they know how to identify a variable and that they can measure it in some way. And in the AP exam, they even have to write down like, they have to write down the equipment they're going to use and how they're going to use it. Like I am going to use a ruler, And with this ruler, I'm going to measure the distance traveled, or I'm going to use a motion sensor to measure the velocity. So something as simple as that they have to do. They have to identify the variable that will be affected. So I'm trying to think what I just did. So I just did how mass affects acceleration. So they have to figure out how can I manipulate the mass and then be able to measure the acceleration. Find a way that you can like what function it's going to be. Is it going to be an inverse or direct relationship? They have to be able to make their procedure, and then the graphing is really big. So I'm going to spend some time on graphing in a little bit, but they do, if they're not on their lab question, and there's going to be one lab question, they're either going to have to design a procedure or make a graph, and sometimes they have to do both. So it's really important that you have your students do this throughout the year. All right, so I decided to start with this one because it's fluids. So an inquiry lab activity could be that you give your students a 2-liter bottle, and then you just say to them what affects the rate that the water leaves this 2-liter bottle. And then to try to get them to work on this, hopefully you'll be doing this towards the end of the year, so they'll be used to doing these labs. You know, what equipment do they need? What can they actually test? How can they show their results? And then if you feel like you need to give them a little more guidance, this handout I have here is for moving fluids. Okay, and then I just give them the question, you know, what's the relationship? This is more specific of the depth of the fluid and the rate at which it leaves the opening at the bottom. And then I tell them, okay, you need to figure out how you're going to measure all of these things, and then, you know, write a procedure, data table, all of that stuff. And again, this would be a pretty cheap lab because you just need really 2-liter bottles and then, you know, a meter stick or something like that. I also have done this lab. I don't know if any of you have this, but I found it really useful to get for my fluids labs is those huge, like I want to say Home Depot paint buckets. They're like the 5-gallon paint buckets. If you could get those, ask like a local place to donate them to you. They're really awesome. And then I just drill a hole at the bottom of it. It's also the same size bucket that every year when my custodians do the floors of my school, you know how they have to wax the floors. That wax usually comes in those 5-gallon bucket bins. So if you can start asking for them now, and then that's free. You don't even have to do anything for that. So that would be an example of a fluid lab. Make it inquiry. Don't tell them how to measure anything, and then you can change the level on that one. All right, so let's go back. Sorry, guys.
I have a quick question.
Yes,
Would
yes.
you do that lab before you explain any relation between depth and like rate, or would you do it after you've explained some of it?
I actually do it like before. So I do it after I've taught buoyancy. So we've talked a little bit about fluids and densities, so they know densities maybe. And then I do it as sort of an intro to Bernoulli's principle. So then they kind of try to come up with the relationship for that and try to see how the height matters. So you can see like in this one here, it says what affects the rate. So they can choose, or if you want to be more specific in that worksheet that I have, it says, how does the height affect it? So if you want to try to laser in their focus more, you can, you know, make the question less broad. In this, you might have different things that they could be testing. I can't think of any now, but they might think of something else. Did anyone have questions on that one? All right, and then here's some other inquiry lab activities that I have. So this is an egg break one. And so I don't know if anyone's tried this. It's also, I used to do it as a bungee jump Barbie, I used to call it. But what you have is this is a good spring kind of constant thing, and it's more of a I would call it more of a challenge lab than an inquiry lab. And they have a spring here and a string and then this mass, and then they have to figure out, well, where can I release this from so that it gets as close to the egg as possible, but it doesn't break it. So this just tries to make it, a little bit more exciting. And they have to come up with a procedure of the measurements that they have to take. You could talk about graphing with this, so that's another good lab that I have there. And the bungee jump Barbie equivalent is we do rubber bands, and then they have to try to figure out how many rubber bands to attach to the bottom of a Barbie, and then we throw her out the window, and then she has to get as close to the ground as possible without like hitting her head on the ground. So that's another good one. This Meet in the Middle is one of the earliest kind of inquiry challenge labs that I do. These carts are really awesome to have, these like little buggies in the classroom. I don't think they're super expensive. I want to say they're $10 to $15 each. And it's a good introduction because they, in theory, as long as they're new, they have a nice constant velocity. And you can have your students try to find the you just give them the cars and you just say, what is the speed of this car? And then if you could get two cars that have different velocities, you put them a certain distance apart, and then they have to predict where they're, at what point will they meet based on their velocity. So this is good because they're going to have to start graphing like position time graphs. So that would be another inquiry one that I have for everybody. I just grabbed this as another example of inquiry. Here's your problem. This would be something you could be doing right now with a penny in a textbook, and you can like adjust the incline and say, how can you do this lab and find the coefficient of static friction? And you can also do it for kinetic friction. They actually did this experiment a few years ago, was a free response question, because it's sort of like a classic physics example. So those are all like, if you are not really sure what inquiry can look like, you don't have to just like throw them a lot of lab equipment and say, figure something out. You can give them, guided inquiry is a good place to be at with this. All right. So what I'm going to do right now is have you go into a breakout room and just talk for a minute about inquiry labs. Do you use them in your class? This way we could do it at kind of a smaller group than everyone talking right now. What problems do your students have when you do inquiry, and then how do you overcome that? And then, when do you let kids kind of go and go crazy with the inquiry labs, and then when do you feel like you have to kind of rein them back in? And then if anyone has any good inquiry labs, share them with your little group, and then we can get back together and then talk about that, because we do have some people here, well, all of you really love physics and have some ideas for inquiry. So I'm probably just going to give you maybe 3 to 5 minutes just so that you can not listen to me. Let's do 5. Okay. And let's see how they go. Open.
Nope.
Oh, there's just no video for you to. Okay, well, so I just did an inquiry lab with my kids. It was on the static friction, and all I gave them was the directions to find the static friction between any two objects. I gave them that they should have an inclined plane and an object that does not roll. And they had to find out how they would do it. Some people use their cell phone to find for the angle finder. Some people used a protractor. Some people used rulers. And it was all a great inquiry lab where they had to design, they had to get their own materials, their own procedure, and then they had to calculate it. I don't do a whole lot of inquiry because they do take a lot of time. But my kids, for the first 5 or 6 labs, I had them write the full lab procedure, materials, everything. So they get used to writing the materials, the procedure, and a graph. Does anybody else do a good inquiry lab?
I did one where I gave my students a giant tub of Legos, and I told them that they had to build a cart, and they had to figure out how to have it with the lowest coefficient of friction, and then they had to race them. We had brackets, and it was fun.
It would be fun.
Hi, how's everything going?
We're just talking about a couple of our inquiry labs.
All right, cool. Do you guys have any good ones I can steal?
No, I did one similar to yours, but it was not, I did not give them as much details. I told them they had to use an inclined plane and any non-rolling object.
Oh, okay.
They had to find the mass of it. They had to find the angle that would get for static friction, multiple tests, graph it, the whole thing.
Perfect.
Do y'all ever use Firefox?
Yeah, I have used that. I have it linked in the thing. Yeah, do you use it often?
I've used it 3 or 4 times.
Okay. That's cool. What do you use it? Like which one?
I've done dropping
Okay.
their phone to find the acceleration due to gravity. I've had them do dropping it, or no, the incline to find the coefficient of friction.
Okay.
Like they put it on a book and then with an object, and then when the object starts to slide. And then, oh gosh, I've used it 2 other times. I can't think of them off the top of my head.
Yeah. Someone showed it to me like, I don't know, maybe 2 years ago. I do it with the pressure. I use the pressure one.
Yeah, and you can do the magnetic field too, which is pretty cool.
Oh, that is nice.
And I mean, there's a lot of them.
Right, right.
So,
All right. I'm gonna end our rooms, I think. Hold on 1 second. And then we'll join together. Hopefully they're coming back. Whew. There's everybody. They're having good discussions. They don't want to leave. Ah, here they go. They got kicked out. Good. Hello, welcome back. Hopefully you all had some good discussions with each other. Did anyone have anything they wanted to share with the group, like a really good lab or a question after chatting with each other? No? All right. Well then
I had one little question. We
yes.
wanted to know where you got the car with the constant velocity.
Oh, Amazon.
Okay.
Yeah.
And is it one that you pull back and then it goes
No,
somewhere?
it's battery operated. I think it's got 4, I don't know, but some kind of battery. Is it
Okay.
C's maybe?
They're fairly cheap too. I got
Yeah,
five.
would you say they're like $10 to $15? Yeah, yeah. Oh, good. Scott put them on there.
Thank you.
Perfect. Yeah. Let me look. Yeah. $10. So it's a nice tool. It's a nice like cheap thing to have in your classroom for sure, especially in the beginning when talking about motion and stuff like that. Yeah. I highly recommend having them. When I had a student teacher a few years ago, we made him like a goodie bag for his first year of teaching, and we definitely had those in there for his goodie bag because it was something awesome. All
I
right.
wanted
Oh
to
yes,
say,
go ahead.
that card
Yep.
is also a really good demo for centripetal force.
The car is.
Yeah, the card, if you just tie a string,
Oh yeah, yeah,
then
yeah.
and then just hold on to the string, the tension from the string will cause the car to actually just go around and around. And that's a good demonstration of why centripetal force is what caused the car to change direction and not speed.
Right, right, right.
Yeah.
Oh, that's a great idea. Thank you. All right. Anyone else? Those were both. Thank you for sharing. That was awesome. All right. Well, we're gonna see that I went on here to get that. Okay. So let's continue on to. Sorry, I did not bring my school computer, which one's okay, good. All right, graphing activities. So graphing is like huge in AP Physics. You want your kids always graphing. You should talk about graphs going on in every single unit. This is really important also with when they talk about multiple representation problems. That's going to be one of the 4 free response problems. So if they're doing a multiple representation, most likely they're going to be doing graphing. So graphs are really important. It's true no matter, you don't have to be in AP Physics. You could be in any physics that you teach. I'd spend a lot of time talking about the fact that slopes are really important with graphs, and also sometimes areas are really important with graphs. And, depending on what you need, sometimes you need the slope and sometimes you need the area. And, this you could do right away. Like kinematics, immediately you're talking about slopes and areas. So they could start getting used to what's the significance of the slope? How can you use the area to find something? I don't know if any of you have kids that are also in calculus. I usually have maybe 1, maybe 2. So every once in a while, I'll mention that, talk about derivatives and integrals. So this here is something I give to my students. It's kind of a classic physics graph thing that I think came out from Tufts like many, many years ago. So these are lots of different motion graphs, and it has like a description here, which graph matches this description, and then things to choose from. And then there's acceleration time graphs. And I don't know, it's like a 10-page document or whatever. I give this to them at the end of every kinematics lesson. It really helps them figure out, do they actually know what they're talking about with graphing? It's really, really conceptual, and it's not, a plug and chug type of thing. So this will also be in the drive. Definitely make sure they do graphing. I also put this activity in here. It's a printout, so it has lots of, position time graphs. There's I don't know, 6 sheets of them. And then they have velocity time graphs. I have like 6 sheets of them. So you have to print them all out, cut them all out. I actually laminated them if you're so motivated to laminate. And you give a lab group this group of graphs. So there's a set of position time graphs, a set of velocity time graphs, and every single velocity time graph has a position time graph to match it. So in the beginning, when you're doing that kind of stuff, these are good lessons to try to do. They have to be able to represent that. And then for me, when I have my students do this, after they have their distance graph matched with their velocity time graph, then I make them write, what would the acceleration time graph look like for your pair? And then we kind of switch around and everyone sort of checks their work. So definitely do some graphing. And then someone earlier was talking about review. So at the end of the year, because I talk about it so much, I give them a review assignment. And what they have to do is they have to go through all of their notes for the whole year, and they have to write down every single graph we've done. So whether it's velocity time, a potential energy curve, torque first time, whatever it is, and then they have to name the graph, do a sample graph, explain why is it important? Are we looking at the slope? Are we looking at the area? And then, when you would use that graph. And then I put the rubric for it with that. But definitely take time every time you're doing a unit, look through and say, what are the important graphs for this? How can I represent what's happening in graph form? So I just wanted to point to those. Oops, someone has a chat. Yep, that is good. So yes, graphing. If you haven't caught that, I think it's important. Now is your time. Okay. All right, good. Now, this is another representation. So we have lots of representations. You could do graphs, and you can also do energy diagrams. So I don't know how many people have used these, but they actually are assessed on the AP exam now. So they might have to draw a bar graph. So let me show you what I mean. So here is an example of, shoot, this doesn't move very well. They're called either bar graphs or LOL diagrams. The L is because this sort of looks like an L and then an O, and then you have another one here. So it's a good way to visualize how the energies are transferring from one type to another. So for example, here we've got like a little cart and it's pushed against this spring, and you can see it has no initial velocity. Then it's going to go through this loop-de-loop, and then it will be at the top of this loop here. So what you want the students to do is use these energy diagrams and create bar charts. So in the beginning, you can see down here it says K for kinetic energy, UE, so that would be your elastic potential energy. I'm sorry, the potential energy of the Earth. Okay, so gravitational potential energy. And then US is your spring potential energy. And then over here, you've got, again, kinetic, UE for potential due to Earth, spring, and then thermal if there's friction. So what I would have my students do is in this initial right here, they have spring potential energy. So they have to come and draw a bar graph, and they can pick however many bars they want. So maybe they say, okay, I'm going to put 4 bars for my energy here. Let me draw this for you for a second. Okay, here we go. Here we go. All right, so I'm going to stop sharing for 1 second so that I can put this up for you. So initially we might have like this. So you would have them have a bar graph here, and I gave 4 little boxes of spring potential energy. And then over here, I have to say how that energy is transferred. So now it's on the top of the loop, so I know it has gravitational potential energy, but it's still moving. So in this one, in my next one, what I would have is 1 block of kinetic and then 3 of potential. So the energies that I have here, I have 4 blocks here, have to equal the energy that I have here. So this, and then the circle is your system. So systems are a really big thing on the AP exam. They have to know what the system consists of. So the way that I drew this, my system is Earth, spring, and cart. Okay, so I'm talking about all of those energy. Yeah, here we go. All of those energies, and then I have it go from here to here. How many people have done these diagrams before? A couple of you? Okay. Has anyone used it with Legos or no? Do we talk about Legos? and using them with Legos. So if you get those 4x4 blocks of a Lego and you can actually like physically have them do the bars, those work really well too. And then I have one thing that I have that my students love, which I highly recommend buying, are chalk markers. And they write these on the lab benches, like my black lab benches. You know, the kind of markers that if you like went to a restaurant or a bar and it has like the specials out front. I don't know. You give them those and they think physics is amazing now because they can play with those. But that is a good one to do. So let me share again, go back. Sorry, we keep going back and forth. All right. So here is like a huge practice page of an LOL diagram. So this is the basic idea. These are your initial energies. So you create, you know, like however many blocks will be there. This in the middle has to be your system. And then you can also have arrows going in and out of your system. So if you don't want to include Earth as your system, you can have like work done by gravity going into it or work done by gravity leaving it. And then your final energies here are the blocks for how those final energies will be like rearranged. So here we have a block of wood. It's going to slide down, hit a spring. And there is friction, so that is important. And our system is going to be the block earth, and then the spring. So we have all of those there. So you could see that in the beginning, we must have given it initial velocity. Yeah, so it starts at a certain speed. So in the beginning, it's got kinetic energy because it's starting with the speed. It's got gravitational potential energy. And then I put my system here. And then I knew that it had friction, so I had to subtract the work of friction. And then when it stopped down here by the spring, it can only have spring potential energy. And if you look, this has 5 blocks. This has 6. So this has to be less if you have some of your work leaving because of friction. And just so that you know I'm not lying, they actually do have you do it on the AP exam. So this was 22. So here's some masses, a spring, things going on, blah, blah, blah. And then look, right here, you have your bar graphs with spring potential, gravitational potential, and then they have to create another bar graph. All right, so you definitely, if you aren't doing bar graphs with your students or this kind of thing, it is something that you should start so that when they see a question like this on the test, they don't get nervous or worried because they've never seen it before. Before I continue with the one that goes with this, does anyone have any questions on that or comments on their bar graphs? Good. All right. So then I'm going to show you this awesome activity that goes with these diagrams. And if you've seen it, that's good. But if not, hopefully this will be exciting for you. So there is an awesome tic-tac lab. So I give them this and I say, all right, I give them tic-tacs actually, and I have them bounce them and create LOL diagrams. So I want to show you the video of this. And I don't always show them this video, but I wanted to show you so you could actually see the tic-tacs bounce. Hopefully she shows up. Here we go.
You're watching Physics Girl. Ever tried bouncing tic-tacs into a cup? Bouncing tic-tacs into a cup is hard. Some might say strangely. See, I was in the best state the other day to come across an everyday mystery, but I noticed something strange. Sometimes tic-tacs bounce higher on the second bounce than on the first. What? If you've ever bounced any round ball ever, you know that the first bounce is always higher than the second bounce. What is going on with the tic-tacs? We're going to solve the mystery with
All right, oops, I'm gonna turn her off, minimize this. Okay, so with this tic tac bounce, then I give them like a whole bunch of tic tacs. I ask them to create, you know, like their LOL diagrams, where's the energy flowing? And then in the end, I also have them ask about torque, you know, like where are the forces applied and different things like that. So we have the video, okay. So what I'm going to do with you now is I'm going to, let me take this and I will put it, oops, I want this here. Copy. I'm going to put it in the chat for you so that you can have the video there. So you and your breakout rooms, I want you to look at the video and try to make your LOL diagram based on the video. And this would be a good time to refresh on the fact that there's rotational kinetic energy and linear kinetic energy, and kind of talk about, okay, how does the linear kinetic energy, potential, rotational, how does that all sort of mix out? Has anyone ever seen the Tic Tac video before? No? Okay, so it's actually like super awesome. So I'm going to give you a moment to kind of enjoy the amazing Tic Tac and try to, and also again, super cheap. You just go to CVS and you buy $3 worth of Tic Tacs, and you have you literally have like you could have a 2-hour lab, but at the very least you have like a 45-minute lab.
I was muted. Hello again.
Hello.
Hi, Sean.
How you guys doing?
Doing great. Have you ever seen this Tic Tac lab before?
That's like the first time I've heard of it. It seems so simple. What the heck? I've been doing like difficult labs, like with a lot more material than just a tic tac.
I've never seen this one before, so I was just looking at the video.
It's so simple.
Yeah, as long as you got a high-speed camera to watch that thing bounce.
That's true. Let's see.
What are we supposed to be doing again? I forgot.
Discussing how I guess we could use this lab so they could understand that there is kinetic energy and rotational kinetic energy. And if that tic tac hits just perfect, some of that rotational is going to convert just to straight kinetic and make it bounce higher. It won't be easy for the kids to understand that.
No, yeah.
So it's tic tac spinning and it just hits at the right edge, then that turn of energy can actually cause it to pop back up, as long as it's straight down kinetic energy.
It'll definitely be fun to do, but like to describe it, for them to describe it, I don't know. And to like put it down on paper in a inquiry might be a little bit more difficult. If it has to be like a lot of detail.
I think if this was sort of an AP question, it'd have to be explained why it could. Justify why. And it might be one of those answers where it has both, it can't go any higher and it can, and you just have to justify it correctly. it can't go any higher because the maximum kinetic energy will be converted to maximum potential energy, and it can only go to the highest point, and you should lose energy every time. Okay, good explanation. But if it does, where did it come from?
It's true. Was that the only thing that we had to discuss? Just all about the lab that she showed us?
I think so. We got shoved in here a little quickly for me.
I know. How's everything going for you though? Like teaching wise, do you guys have what's your experiences? Because this is the first time we've all been in the same group together. This is like my first year as a physics teacher. So how about you guys? As a AP, yeah, as a
Any
physics and AP, yeah.
Oh,
I'm moving from college to high school, so
Wow.
it's pretty much the same.
I've taught all kinds of different levels of high school physics. Before there was AP Physics 1, I did IB Physics, so I've done a lot of them. And it's got interesting for AP Physics the way they're making them explain it rather than calculate. Less
Yeah.
on the numbers, more on the understanding of the physics.
More like conceptual understanding rather than
Yeah. Can they explain what's happening?
like
Can they
even on
tell
the
you why when those two cars collide,
yeah.
why when they stick together, they have to be going slower than the original speed? Or if they are going slower than predicted, where did that energy go?
A lot of comprehension, huh? It's different from
Yeah.
so it's not as is it as math heavy? Like let's because I haven't seen the AP exam. I seen the last year's one. I don't know how this year will we be pretty much the same. It's
It'll be
just
a
less.
little bit less because of adding fluids.
Oh yeah, that is right. And then they don't, and the answer are a lot more shorter than paragraph form. I heard. Like
Oh,
the free
three or
response.
4 sentences. You don't want them to try and write a novel. They don't get, and I tell them, you don't get any points for trying to prove that you're smart.
Just get
Tell
to the
them
point.
physics, tell them the facts. Like this is an engineering course. If you ever took engineering courses, they want to
Yeah.
know the real facts. This is how you get it. Don't tell me all kinds of fancy words. Say you know fancy words.
Just get to the point, right?
Yeah.
Get to the meat and potatoes. That's good. So not too bad if they just know what they're talking about. As long as they know what they're talking about, right?
Yep.
They use the right terminology to answer it.
Really good with the vocabulary, and they can use the formula sheet to help them formulate their answers.
That's really good too. So just use all the resources you have during the AP exam and
Yeah, it's like
understand
you
what
may
to
not know exactly, but if you know the right formula, you can probably get some points by explaining what you might do.
use. I like that. That's good. Because I have experience. Because of course in college if you're like a biology student, you have to take like 2 semesters of physics. Physics was easy. I enjoyed it a lot. It was mixed conceptual and algebraic calculus based. So
That wasn't what I took in college.
Yeah.
I took calculus-based physics 1, computer science 1, all those at the same time. It was great.
Wow. And how long have you taught physics now? Is it like your
On and off for the last 18 years.
So they sometimes throw you in the
with this new AP Classroom or this new Physics 1.
Ooh.
I stopped teaching physics back when Physics 1 became a thing.
Was that when it was just like a mix with chemistry? Are you talking about when it was like chemistry?
Physics B. It was a different.
Oh, it's called Physics B. Dang.
Which covered more physics and more math.
But now it's all a lot of conceptual now.
now it's all mostly mechanics and more understanding.
Yeah. I noticed that too. I was like looking, I was like, man, where's the math problem? It's not as much as I used to remember.
Yeah.
So the kids should be doing well in like the AP exam, as long as they understand they get their probably know how to apply it like in biology. Biology is more memorization than understanding, I would say. But here you have to actually know how to apply it. Read, understanding to
Especially to
read
a problem.
questions. These questions can be complicated, so you have to like really read it carefully.
Yeah, like she was saying earlier, identify the variable. Make a procedure to test that variable that
Yeah,
is measurable. How did you
yeah,
measure it?
that's true.
Did you make a table? Okay, what is in your table? Did you graph it? What would be your graph?
Yeah,
If they know these things, they say, oh, and then the slope would be this. And they're explaining everything
yeah,
without actually doing the experiment, which is really tough to do.
yeah. You have to do the experiment to understand it as well. I think it's a lot of physics is lab oriented. Like lab is comes first, and everything else will follow. Because if you
Uh-oh, we're being kicked out.
oh no, okay, we'll see. See you guys.
Bye.
See you guys.
You tell us it's time to go. We got
That's right. You listen to directions.
They're trying to milk that minute.
Yeah. They're enjoying their time. Some people had some good ideas. They're gonna come back, so that's good. It's nice to learn from each other too. You never really with other, well, I'm not with other physics teachers very often. There's not like 8 of us or something where we can get together.
Yeah, it's not like chemistry or biology.
All right, good. We're coming back. All right. Oh, I'm missing people, but oh good. Lauren just put a link because we were talking about whiteboards and dry erase boards. So this is a board that has like a white background and then on the other side has a grid. I don't know. It seemed like something cool to have, so thank you for sharing and putting that on. Did anyone have any comments or questions after meeting with each other about the tic-tac stuff or just the bar graphs and LOL diagrams in general?
We had a discussion for a while about whether or not it could be like an inquiry lab, like if you could use a video recording to measure things, or if it would be too hard. And yeah, we had a little bit of like a debate about that. So I'm curious what you think, having done it.
For me, I don't think I don't usually have them collect like a ton of data. For me it's more conceptual, this one, and being able to, realize, why does it bounce higher, and being able to finally add in the rotational energy because we start without it and then we move on to that. So that's sort of how I treat it, is more conceptual and focusing on the graphing of it. Did anyone have any other opinions on that?
Yeah, just having never done one, I kind of just started to try to throw something together in a Google slide, and I quickly realized that I'm not quite sure all of the variables that we would be using exactly in this circumstance, and then I guess I'm a little bit confused on what would end up going in the O part of this one.
Oh, in the system part? So you can have them change that. Like you can say, okay, I want you to make an LLL diagram where the only thing in the system is the tic-tac. And then you could say, okay, well, now I want you to do it where it's the tic-tac and Earth. So what goes in the circle is defined at the beginning of the problem, and you are allowed to tell them what to put in that. Does that make sense?
Yeah.
Okay. So like if they don't have Earth in their system, then they can't have any potential energy bars in the bar graphs. It has to be like work done by gravity, either in or out, depending on which way it's going. I also think that this kind of this idea of the rotational kinetic energy can be, it's new to them, and rotation tends to be a more difficult unit. I think that if I had them do too much math, I might lose some of my weaker kids. So I try to keep it like a little bit more conceptual, and maybe like, my brighter students, I could push them to maybe getting some data, but I think mostly I keep it conceptual. Did anyone else have a question or advice? No? All right, then I'm going to go back to my slides here. So hopefully you found that sort of interesting. The kids also like it. Plus you can make it like, some years I've had them do like, make a TikTok about your Tic Tac, because they like to do stupid stuff online and show everyone. So that can help. And then you can also do like a good free body diagram with this. Like so this is good for multiple representations, because you could do LOL diagrams as a representation, and you can also do like free body diagrams as a representation, because that is one of the free responses, to have them look at it in different ways, so like when the Tic Tac is hitting like perfectly horizontal or perfectly vertical or somewhere in between, talking about where the forces are acting, and then if the forces are acting there, what's the torque being exerted on the Tic Tac. So it's got a lot of good physics. You could like spend tons of hours on this. All right, so we did that. Good. Okay, so this is sort of my big thing that I make my students do all the time, and they don't like me in the beginning, but then they get much, much better at it. So this is the idea of linearization for your labs. And they're most likely going to have to do this on the AP exam. Like it's always on there. So what I mean by linearizing data is that they have to have, there are two different variables, and it's not always going to be that your independent variable is on the X and your dependent is on the Y, and then you get a nice perfect straight line. Sometimes you might have to inverse one of your data, you might have to square it, might have to square root it, but they need to start learning how to manipulate their data in order to create a straight line. So that line can give them like whatever was constant in that lab. So the thing that this addresses is, science practice number one, just creating representations for your physical phenomenon. So it's also a really good area for you to improve your students' performance on the AP exam. I've done grading like a bunch. I don't know if anyone here has done grading, but I highly recommend it. If you need advice about that, let me know later. It's surprising how many students lose some like really easy points for this. So I'm going to just show you, I'm going to press both these things right now. Okay. So I'm pretty sure you went and looked at like old AP exams with Joe on the video, and he talked about scoring guidelines, but I just wanted to point out specific for the graphing. So sorry for the scroll. Okay, so this is actually, this is a while ago. So this is when circuits was still on AP1. It's not anymore, so don't worry about it, but I just wanted to show you the idea here. So this is the classic like Play-Doh example where they're changing the length and the area, and they're measuring voltages and resistance. So they need to figure out, okay, what should I put on my X? What should I put on my Y? And then so that I can get the resistivity of Play-Doh. So in the grading part of this, there are like 3 or 4 points for just like dotting or plotting their points. Okay, so you can see here, this is a grid. So they had to realize to graph R and L over A. Now they get a lot of points. So this is like a 12 pointer, I think. So 1/4 of it is just this graphing. So they get a point for plotting it correctly. It's actually kind of terrifying how many kids do not know how to plot. So I used to be a teacher that did like everything on Excel and always had them do Excel things, but really make sure they get pen to paper because they are going to have to figure out like, what kind of scale do I need to make? Can I actually plot points? Do I know that resistance is in ohms and I label it properly? And L over A, the unit is this. So they get a point for making an appropriate scale. So you can't have like the graph has to take up more than half of the graph. So you can't have it like just in these 4 little ones right here. You need it to be nice and big. They have to be able to scale it appropriately. Then labeling the axis is really important with units, and then actually plotting the point and drawing a best fit line. So sometimes they'll even get that 4th point of drawing a best fit line. So a lot of times when I'm not doing inquiry, I'm doing more of this kind of what I call linearization of data. One trick for the exam, it doesn't really help their physics, but let's say they had no idea what they wanted to graph. And the problem is they don't want to lose all the points. So what I tell them to do is if you are totally lost on the real AP exam, just pick one of these things and put it on the vertical, pick one of these things, put it on the horizontal, and with what you have, start graphing so that you're not losing like these 3 points. Okay, so that's not great physics, but if they're worried these points aren't grading physics. These points are grading, do you know how to graph? So they should at least get those points is what I think. And then like 2013, or I'm sorry, 2030, and then I'm going to show you the example of the labs. But before I do that, I just wanted to stop for a second. Did anyone have questions about the grading one that you saw with Joe / what I just showed you with the free response and the graphing? Do you guys all make sure you do pen and paper graphs? I hope don't just have them do sheets. Because it is like, it can make them get from like a 3 to a 4 if they know how to graph, or like get them from that 4 to the 5 if they know how to do it. It's a skill that is shockingly lacking for these kids. All right, so this right here is,
Question on that.
oh, yeah.
So you said, so if they could plot stuff, even if it doesn't come out as a line, like if they plotted the points,
Right.
and what if they drew a best fit curve, which isn't effective, but like would they still potentially get point for that, or no?
Yes, they can still get a point for that. Yeah. So yeah, encourage them to do that. At least pick something, say in their desperate times when they can't think of it, at least get those 3 points. Yeah. And it's almost always 3 out of these 4 points. It's like, can you make an appropriate scale? Are your axes labeled and units appropriate? Do you know how to plot points? And then can you draw a best fit line? And in some way, one of those 4 things are addressed. So sometimes graphs are 3 points, and sometimes they're 4 points. Scott, did you have a question, or was it?
Yeah, so
Okay.
while I was watching the video that was assigned to us, he talked a lot about little things like, for gravity, you have to use the exact specific, there's a range of symbols you could use, and then
Oh,
if you
yes. Yeah.
drew an arrow and the arrow point was disconnected from the line, you wouldn't get the point and things like that. Do you by chance have like a cheat sheet that has good ideas about how to avoid significant point losses for little errors like that?
I have it for free body diagrams because I run like the hold on. Where did I put? Someone asked for something else too. Oh, here it is. The AP1 PowerPoint. The free body diagram. I can add that to the drive.
Thank you.
I don't have it. I don't really have it for like all my tips, but I guess one of my other ones is sometimes like question A, like B, C, and D need your answer for question A. And if your student is clueless with question A, I tell them just make something up. Just say acceleration is 3 and then use 3 for the rest of the problem. So instead of getting the whole problem wrong, they only get question A wrong. That would be another one of my, I don't know if Joe said that, but that would be another one of my tips, because you don't, usually after the first question, there's no more points for the right answer. It's did you substitute? Like it's always like a substitution point for the rest of the thing. So that's another like testing tip that I can think of. Did anyone else have questions? All right. And let me show you this. Okay. So I created this like through the years. I have made like tons of linearization labs. And this year I was excited because this first lab on here was the AP question. So it's always here, let me, and then I'm going to link this for you guys in a second. So I don't know how many pages this is, 10 pages. So it's 5 different labs, 5 or 6. Sorry, I know I'm going fast, but I want to go to the top. All right, so here we have parallel and series springs. I just did that this week. So I have series springs and I'll say, okay, you have 2 springs, a mass and a ruler. You got to figure out how are you going to get the spring constant of the spring. And I make it look exactly or as close to what the AP exam looks like. So when they get to the graphing problem, my students never are confused. They're like, oh God, another one of these graphing problems. And they know exactly what to do. So I give them on the real AP test, like mass will be filled out, obviously, and spring will be filled out. But because we're making this a lab, I leave this empty, I leave that empty, and then I leave 2 columns because sometimes, not in this one, although they could do weight, but they might have to, adjust their data. They might have to square a velocity or do 1 over the mass or 1 over the acceleration or something like that. And then I ask them, okay, what do you have to graph? What needs to be on your vertical axis and your x-axis in order to get a straight line? And then I use the exact same graph from College Board so that like they're used to seeing exactly what it looks like. And then using your best fit line, find the numerical value for your spring constant. So I am going to copy this, stop sharing for a second, and put it in the chat. If someone could open that and just see if you have, like if it's working, if someone could give me a thumbs up. You don't have access to it?
Stop posting it.
Oh, in the chat it's not?
No, or not on mine.
You only shared it to
Oh,
one.
shoot. You know why? Because someone direct messaged me and then I replied to that instead of doing it to everyone. Thank you.
Happens all the time in Zooms.
Yeah.
I have kids that take over my chat like that.
Oh, I made it so you guys couldn't know. All right, how about now? Does it show up now? Yeah. And then how about can you actually open it? Question.
Nope.
Showing request
Alright.
access. So.
All right. So, oops, sorry. Let me go back to the share.
Oh, what a good boy, Flash.
All right, so copy link. I'm gonna try again. Share.
Works now.
Oh, it does work now? Perfect. Okay, so these are, I don't need to share, save, get out of here. Okay, so what I want you to do right now is I'm going to give you maybe 5 or 10 minutes and look through these labs. And then, what's that? And then what ones do you see that you could actually like use right now, or maybe not now, but you're like, oh, I can use this with or this makes sense to me. And then also with your breakout room, I want you to try to come up with a lab that isn't in there, but that you think you could create into a linearization lab. Does that make sense? Okay, so scroll through, see what ones you like, and then I want you to come up as a group, and everyone's going to have to share. Not everyone, but every group is going to have to tell us a lab they decided they could linearize or do this with. Is that okay? I'm going to switch it up a little bit. Recreate room so that you have new people to meet. And I'll
المشكلة هو قاعد فات على المجرون.
Some of these they get linearized just from what's already there. They don't have to really do a whole lot to, which is nice. This energy one, they'd have to do something too to make it linearize.
يا جدع سبحان الله.
المساحة، نحن لا نتكلم عن شخص لشخص. فمثل ما سبق قبل الأستاذ عمر، أنا لم أجمع معرفة شخصية. الرجل ما بينه معرفة شخصية، ولكن هو أو بينهم جميعا، ولكنه رد على ما يطرحه من محتوى وأغاني والأساليب التي اتبعها من سرقات حقوق الآخرين والتسلط والتلف. فأشد ما يصيب بدعوتنا هذه أو ما ندعو له الذي هو هدفنا بذلك مرضاة الله سبحانه وتعالى والبر بأهلنا والسنة وحماية أطفالنا من خطر الشعوبي القائم المتجدد في التاريخ. فمنذ سقوط دولة العرب الدولة الأموية ونحن في مرحلة الدفع، جهاد الدفع مع المجد الشعوبي، والآن يعني في مرحلة انتقالية وفاصلة التاريخ نريد أن تنهض الأمة لتتسمى فعلا بأمة حقيقية وتعود إلى ما قبل عام 132، فيتحول جهاد الدفع إلى جهاد طلب لنقضي وندق المسمار الأخير في نعش الشعوبية. فما نقوم به هو محاربة الشعوبية، هذه من أساليب الشعوبية أن تجعل من يتكلم بلساننا وينادي بدعوتنا ثم نعرفهم بلحن القول. وطبعا التاريخ مليء بالأحداث ومن المنافقين في المدينة، وبعد ذلك من دخل الإسلام بالاسم من أجل الطعن في الإسلام من الداخل ومن أجل نقض دولة العرب من الداخل. فعلينا أن لا نكرر أخطاء أسلافنا الذين نتربى عليهم ونلومهم لغفلتهم. فعندما نقوم بهذا الكلام وبهذه المساحة نحن بارين لأهلنا أن لا ينخدعوا بمثل هؤلاء ويعجبهم القول أو ما اتفق معنا بنسبة ونلتقي. لا نحن دعاء، هناك حق وهناك باطل. كذلك يعني هناك من ينشر مواضيع يضيفها لنفسه ويترك مجهودات وأفكار الآخرين، مثل ما نحدث مع صديقنا الظريف وسام العبد. هذا رجل مع أكثر من سنة يعني أكثر يعني بدأ يظهر يعني شبه قناته، يعني قناته عبارة عن يعني شبه عبارة عن سوق جمعة أو سوق بالات، يعني ما تعرف تنمية بشرية، ما تعرف علم حديث، ما تعرف تاريخ، ما تعرف شو بالضبط. يعني فهو شخصيات يعني عبارة عن حالات نفسية وأمراض كانوا يعني مستبدين في غرفهم وواجهوهم ووجدوا متنفس من خلال هذه المواضيع مثل ظهور يعني الشخصيات مريضة نفسيا ومنعزل ويحب يعني يشوف نفسه
go through 0, and you want to make, and sometimes the intercept is a meaningful number, and they need to know conceptually what that meaningful number is. Yes, Thomas.
Another thing to worry about is they must have even division so they don't accidentally linearize something that's not linear.
Yes. So their scale is like
Scale is important.
right. Very, very important. And a lot of times, they will, like, with each of the big things, they'll just actually literally label their data points on that and then label the it's bad. It's really kind of horrifying what you see on the AP exam when you grade. Has anyone ever thought about grading? Yes? No? I have to tell you, it's amazing. Don't you dare shake your head, Thomas. It is so good. And did he talk about it at all on the video? I should have watched the video.
Very briefly
Did
mentioned.
he put the link?
No.
I'm gonna
Yeah,
get that link. He
I think
did?
there was a link, yeah.
Oh, AP Reader. Hold on. I'm gonna put it right here because I would say it was the absolute before I started doing these, the best PD that you could like ever do. You're basically spending a week with other physics teachers like day and night, and the grading is like actually kind of fun, especially like you get really fast and then you try to beat the person next to you, and so while yeah.
I've done AP Environmental Science grading a
Oh
number of
yeah.
years.
Did you like
And
it?
I loved it. I loved it. I
Right.
became a better teacher.
Yes,
and,
yes.
networking with other teachers was great. I learned a lot about behind the scenes of the test and
Mhm.
why this and why that. And so I think I was able to teach the course much better
Yes.
having graded. And so yeah, great PD. We went on some field trips while we were there and visit
Yep.
museums, and we had lectures with some of the professors at the university. This was in Nebraska and Cincinnati and different locations. So I loved it. So I would love to do AP Physics.
Yeah, definitely.
Yeah.
And if any of you do like really want to do it and do apply, if you send me an email, I can like star your name with the chief reader or whatever, like, oh,
I'm applying right now.
oh, all right, good. I'm gonna write that on my to-do list too. Also, if you do go, do it. Don't stay home. Like that is an option to grade at home, but for your first time, I highly recommend going there. There's like events every night. I don't know. It just is super rewarding, and things like this you learn like going through the data points and all of that stuff.
Do you actually go grade over the summer? Is that when it occurs?
So I guess it depends what you consider summer. So for me, I do miss like the last week of school. And hold on, I'm putting different. Sorry, I don't want to lose this. So I can look right now since we're asking reading dates AP 2025 it would be, right? Okay, so we're in Tampa, although I talk big game. I say that I'm going, but my daughter's graduating high school this year, so I'm not going this year. So you could take my spot. All right, physics is in Tampa, and it's June 11th through June 17th. And you have to go from you have to be able to travel on the 10th and travel on the 18th. So you have to be able to be away from home that long. So that is kind of a lot.
So all of the actual grading of people's tests happens in that period of time?
Yes. Except for so every once in a while there'll be like late tests that don't get to like ETS in time, and then they'll send them to like the exam leaders and the question. Like if you're just a first year reader, you will only grade during that week, and it's not like you're going to grade any other time. Yeah.
Thank you.
Yep.
Can first year teachers grade?
So you are
like if it's your first year teacher?
Yeah, you're supposed to grade. I think. Well, it used to be very strict. That you had to teach for 3 years. but depending on how desperate they are for readers,
Oh, yeah.
they bend their rules.
Okay.
Is
Um,
there a place like we can see the qualifications or other
yeah,
details?
if you go to that link I sent you, did I put it up there? Oh yeah,
Yeah,
I
there's
did.
just been other stuff in between.
Okay,
It's up
sorry.
there.
I was like, oh God, what did I do? Yeah. Oh, you went to Glastonbury. Very nice, Joe and the. Yeah, that should. I think it's Richard asking me that, but it
Yes.
should tell you. It should tell you on there the requirements. It used to be 3 years teaching AP, I think it is. But again, they might have switched it. Because
Thank you.
yeah, I just recommend it because you just learn so much, and these little things that we're learning are like super cool and important. Did anyone have any questions about the linearization, or did anyone come up with a good one to add to the group at all?
I would just mention that if people haven't kind of glanced at the student workbook that is in the overview section of AP Classroom, it has a lot of good assignments, and so I was just glancing at one that was about height versus time squared data, so that was a decent one.
Yeah, the workbook is really good on AP Classroom, and I'm pretty sure I have it in my drive broken up by it all in PDF files broken up by topic too. So we will get to that soon. All right, so I think this is the screen I want to share. Yes. Okay. View slideshow. All right, so we did our linearization. Oh my gosh, we don't have a lot of time. Okay. Okay, fluids. So some of you, I don't know, maybe not, but a lot of people were nervous about the fact that fluids is being added to AP1. So taken from AP2, adding to AP1. You shouldn't be scared because it's like the lady who runs AP1 calls it fluids light. It's not terrible. So just to point out, obviously, like when you go to AP Classroom, if you go through, you can look at all the specifics, but basically you're going to talk about density. Most of the kids are going to know density, especially if they've already taken chemistry, so you're not going to have to spend a ton of time on that. Pressure, so just knowing like pressure is force per area. Talking about fluids in terms of Newton's laws and buoyancy. And then, so this fluids and Newton's laws, that's basically like your buoyant force. So they need to be able to talk about, is the object going to float or sink? How much will it, how much will be above water? How much will be below water? And then fluids and conservation laws. So with that, it's talking about using Bernoulli's principle and the equation of continuity. So it's not a ton. They took out a lot. And I sort of mentioned in the first module that some people said they are going to actually like put this fluids and Newton's laws in their force unit. And then they're going to put fluids and conservation in their energy unit and not even like think of it as a separate unit. I'm not taking that approach. I'm going to do like a separate unit and almost look at it in terms of review. Like, oh, we've used Newton's laws. Here's just another force. It's called buoyant force, and this is how we're going to use it. So that is the basic idea of fluids. And someone, and this will be in the drive under my fluids folder, took a bunch of old free responses with fluids and wrote them the way that like an AP1 question will be written. So if you are, obviously AP Classroom has a ton of free response problems, but this is like just broken out specifically for fluids FRQs if you were nervous at all about this. So this is like the classic moving fluids and figuring out how fast it's going to come out of the tank. It's basically been said that if there's a fluids problem on the AP exam, it's going to be this kind, where you have to figure out, how fast it's going to leave the tank, like a hole. See, you can see this, a hole at the bottom of the tank. It's going to be that kind of thing, or it's going to be something in water where you have to draw a free body diagram and like calculate the buoyant force, find the net force. This would be in equilibrium, so net force would be 0, but maybe find the tension force. But if you're going to have a free response, that's sort of basically the 2 you're going to have. And it won't be anything like crazy after that. And I have those fluid things for you. I also have a set of fluid labs. So if you're light on your fluid stuff, I tried to put together some stuff here. So I always like to do like challenge type labs. So in this one, they have like a 2-liter bottle or not, if I have to find a smaller one. And then they have to figure out, I'm going to give them a cup, and then they have to put a cup on the floor where this is going to land based on that. And then I give them bonus, like I'll make a target, and where it lands on the target, that's how many points that they'll get on their test or something, because they love bonus points. Then we have this, we kind of already talked about. This is a lab I really like. Ooh, sorry, it went too fast. So in this one here, and again, you guys will get all of this. I go to the dollar store and I buy, enough helium balloons for each lab group. And I give them a balloon and it has string, and then I give them a bunch of paper clips. And what they have to do is I tell them to add the paper clips so it's in like neutral equilibrium. It's just like, it's not touching the floor, it's not touching the ceiling, it's just kind of in the middle of space. And then when they get to that point, they have to figure out, okay, what is if I were to mask the balloon, mask the string, and mask the paper clips, what would that be? And then I only give them density of air, helium, volume of ellipsoid. And when they're 100% certain, I have them pop their balloon and they come up to the electronic balance and they mass it. And then their grade is based on their percent error for the mass. So if they're within 5% error or less, they get like 100, and then I kind of scale down from there. And then so they really like that lab because it's sort of a challenge, and it's a good buoyancy kind of thing. It's also a good buoyant lab because it points out the fact that almost all of our examples when we're doing problems are like water or oil or something like that. So to be able to talk about the fact that buoyant force can be supplied by air is kind of interesting. And then I have a couple, this is like a random buoyancy lab, but I put like, I don't use all of those, but I've used them all at some point. So feel free to steal that. All right, this I used to do when I run a week-long workshop, but we only have 3.5 hours together, so we're not going to do that. All right, so if you weren't excited about fluids, you should be now, because I'm going to show you my cardboard boat race. I'm going to stop for 1 second. How many people do the cardboard boat race? You need to start doing that's what I say to you, okay? You need to start doing the cardboard boat race if you don't. Oops, someone put something in chat. Is it something I need to see? Oh, okay. Share. Here we go. It is like a huge event in my school. Like the pool deck is totally full. We actually have to kick people out. So these are all the rules. Basically what they have to do is I only give them cardboard. I only give them like clear packing tape. And they have to make a cardboard boat, and they have to be able to fit 2 people in the boat, and they have to go there and back. I also have a write-up with it, so that's all in there too if you want. But I figured I would show you, and this is the grading guidelines. Again, all stuff. I know I'm like sort of doing fire hose teaching with you right now, but this is from, so you can see what it looks like.
Keep going. Okay, we got this, guys.
So, hold on. I want to see if I could get to the full deck, so you can see all the people that come, but I don't know that we can. Nope, this video doesn't have it. All right, but anywho, so I highly recommend doing this. I don't know. So for me, the AP exam, obviously for everyone, is in May, but we don't end school till like June, I don't know, 15th, 16th, something like that. So I'm always looking for something to do. And this is what we do during that time. And it's a lot of fun. So if you are in that situation where you have like 2 or 3 weeks after school is done, this is like a fun assignment for you to do. So I thought I would just share that so you could see that there. All right. Okay, so ranking tasks and being able to like say like this whatever force is great. Oh, you don't have a swimming pool. Boo, go to a lake. I do. One of my friends, her school does not have a swimming pool, and she actually invited all of her friends to her own swimming pool. I don't know that I would recommend that, but you could do that. So anyway, Tippers is they created these tasks, these ranking tasks for students, and they're really good for conceptual understanding of physics. So there's like several similar situations where there's only like a little thing that's different about them. And students need to, for the ranking one, they need to say, okay, this has, let's say, the greatest acceleration, this has the least. Well, these two are the same, and stuff like that. Yes, I'll share that. And then the big thing with this is in the beginning of the year, I have my students just rank. And then as the year goes on to help with like, you know, scaffolding type stuff, I make them also write the justification because on the free response and even in the multiple choice, one of the types of multiple choices, they'll give you a setup and it will say yes, because, no, because, no, because. So they have to be able to have their ranking and then also a proper justification. Okay, so things that you'll see in the tippers is that it's not like they're going to need a calculator. So they can do all of the math in their head. And a lot of times it doesn't even require math. It's just a conceptual understanding of physics. And they are kind of meant to be tricky to make sure that they understand like the slight, you know, altering things in the slightest could make a big difference. And then again, having them explain is really important. So not just have them do the ranking. And then sometimes I have them say like, how sure are you? Like, are they really confident? Because it's kind of interesting to see how confident they are. So here is an example. This one's not a super hard one, so I'll leave this on here. So here we have a curved line. This would be a really beginning of the year, and they need to rank the slopes from greatest to least. So they're looking at like A, B, C, and D, and then have to, you know, where is the slope the least and where is the greatest? That one's pretty easy, early beginning of the year one. And then we have, actually, I just gave this one, I think, today. Sometimes I use it like as a warm up. So here we have 6 different situations. They're going to start at rest and it's a frictionless surface. And they want to do greatest change in speed to least change in speed. So I'm going to leave this on here for like a minute or two and see if you can rank them. All right, so does anyone want to yell out which one/ones they think is the greatest change in speed? Is someone answering?
E
B and E?
and B.
Yeah, E and B, followed by D and A, and then C and F. Now, like if you were to like probably the next one, not that I posted, but that would be on here is it would be like rank the situations from greatest change in velocity to least change in velocity. So then you can kind of have your students talk about, well, how are the answers going to be different if I am talking about speed versus talking about velocity. And then here, we don't need to do this one right now because we're running out of time, but these are blocks with pulleys and then do their, net force and rank them least to greatest. And then the next one might be like, what would be the acceleration for those? So I don't know. I've always liked doing these ranking things. I think it kind of makes my students realize what they don't know, so they're really good at plugging and chugging, but sometimes they have to think about like the difference in verbiage or things like that. So we're not going to do so the way I use this is sometimes I can start a class with this, like I'll just have it projected on the screen as they come in and they kind of talk about it. I use it as review. So like before midterms, I might print out a bunch so they could start thinking about topics they haven't thought about before. We can have like big classroom discussions, or I could just do a demonstration. So some of these you might be able to actually demonstrate and see, if your answers are correct. Or a pre-lab activity is good too. Before I do this, did anyone have questions on that / have used the ranking test before and thoughts on it before I move on? No? All right, good. So then I kind of
Sorry, one thing. I was thinking, I was looking on Amazon yesterday at some like buzzers that are sort of in the style of those game shows. And I was thinking it could be fun to do like in groups, like the groups have the buzzers, and then you could do a question like this, and then they could race to answer something like that.
Yes. Anytime we can make it more fun is good. So buzzers are good. I'm all for that. And I like these two in, like you said, working together. It's nice to have them discuss it. So a lot of times I'll have them discuss it with each other and then they on their own have to write about it because they do have to get better about writing for AP1. That is like a big focus for that. Okay. So in case you are somewhere that doesn't have infinite money, there are some ideas that I wanted to share for inexpensive labs that I have. So, all right. Someone was talking about, okay, how do your kids all of a sudden know how to do these linearization labs? So I do a circle lab to start the year. And I just give them a bunch of different circles and they have to measure, they can't calculate, they have to measure the radius and then they have to measure the circumference or the diameter, however, it doesn't really matter. And then they have to figure out what are you going to put on the x-axis and what are you going to put on the y-axis so that your slope is pi. And then after they do that, because that one is sort of easy, you don't have to like square anything. So after they do that, then I have them do the area. So I give them the same objects and then I give them like graph paper with squares and then they have to measure like by counting the squares as best as they can the area and relate radius to that. So this is basically a free lab, but it's a really good early linearization lab. Probably too late for this year, but if you're just starting out and teaching them linearization, then maybe it would be okay. One of my friends showed me, I happen to have like meter stick balances, but if you just have, ring stands and binder clips, like you can just make your meter stick balance this way. You don't have to buy the like the fulcrum stuff that you could get in whatever company you're using. So this is a kind of cheap way to do torque. Also, if you want to beef up your torque, what you can do to add fluids to it is you can put, weight on this end and also a balloon on this end upward, and maybe have them calculate, all right, what is the buoyant force produced by the balloon? That's kind of how you could add some fluids into that, which I've done in the past, and it works out well. Okay, so then this is an app, Firefox, on your phone. It is free. I think we talked about it in one. Here, let me copy it here for you and put it in the chat. Yeah, I will give you guys the slideshow too. I know I'm going through everything. But okay, so here is an app on your smartphone that you can have. So if you don't have like Pasco or Vernier equipment, but you want to be able to make some measurements, this is totally free, and it uses their phone. And it can be used like as sensors, and they can take different data and stuff like this. I forget, someone said Lord, no, I don't remember who, but someone was saying that they have used this in the past. You can actually, one thing I do with fluids, I'm going to show you on my app. Okay, is that? Yeah. So like it looks like this, whatever, and there's one that says pressure. And if I press that, it will read the pressure. And you can actually like go to the top floor of your school and go to the bottom floor of your school, and this will register the difference. So you can take measurements as far as like you could show that pressure depends on depth or height, however you want to do it. And this is like a cheap and easy. The app is totally free. So if you want, that is another thing here. Let's go back to cheap. I don't know why soup can. Oh yeah, so okay, so some of those moment of inertia discs can be expensive. So if you wanted to do it with a soup can, then you can, kind of talk about that, or you could do a sphere, roll that down, and then move over to a soup can and kind of talk about how the moment of inertia would be different between that. Okay, for fluids, you could go to the dollar store in the summertime, not right now, but you could get like these kind of like water guns, or you could get the ones that are just the long thing that you like fill with water and then push, and you can do some fun like projectile / fluids stuff for that. So that's all inexpensive lab ideas. I love this lab. It's a little spring toy lab. So you get these, you can buy them on Amazon. I got them in Target though too. And it's a really good lab for multiple representations. So what I do is I have my students push these little guys down, and then they videotape them, and they jump up into the air, and they have to try to figure out, well, what's the spring constant of the spring? So I actually just give them this, and I say, find the spring constant of the spring of these little alien things. And then I also have them for, 3 different, I'll say like when it's compressed, when it's here, and when it's at the top, draw your LOL diagram for those 3 different situations. And that's like super cheap because those guys are like, I don't know, I got a pack of 20 for like $4. They do disappear remarkably, but I'm gonna go back to that in a second. To the part where you can do it online when I talk about that. Flying Pig Lab. This is a classic one. So this flying pig, you make a conical pendulum with this, and you can find the velocity using like the radius and all these different things. So I recommend the pigs. I think you can also get airplanes. I actually have airplanes because I'm not cool enough to have pigs. But that is, I don't know, they're probably like between 10 and 20 dollars. So they're pretty inexpensive. And then again, I'll have that, and I'll show you all this. Ooh, this is free because hopefully you have toilet paper at home. This is actually a really good lab. So what you have them do is you give them 2 rolls of toilet paper. One they're gonna drop, and then one's gonna roll down. Like it's gonna hold it, and then as it falls, it will roll. And they're like, if you had them at the same height, they wouldn't hit the ground at the same time. So what they have to do is calculate the ratio of heights so that it will hit the ground at the exact same time. This is a good, cheap and easy lab for you to do. Yeah. Did anyone have questions on those? I do have all those in the Google Drive, so you didn't have to like memorize them, but those were all different things that you could do for the class. And then the last thing on my slides, and I will probably just share the slides and not really go over this part, are different online resources, which I'm sure you already know about. PhET is kind of like been around forever. Oh yes, fine, good. The Physics Aviary I really like, in case you haven't used these. These are all different. Oh, why are they not coming? Okay. O Physics. Oh, it's and then Pivot. So these 3, the first one, Pivot, Physics Aviary, and O Physics, are all ones that you can go to that are free. Pivot is one that you do have to pay for, which my school does do for me. I don't know if I can log in because I totally forgot my school computer. Shoot, no. I will give myself 30 seconds to do this, and then if I can't. All right, cool. So there are tons of labs in here, and basically what they are is they're doing a lab that you might not be able to do with equipment that you have. So I'll do physics here, scroll down. All right, so we'll just do this, whatever. And deprint. Okay, so we could preview this. So these are all videos of labs that, someone else has done. And your students can, what they'll do is they'll watch the video. So they'll see this moving. And then so the balls are all released or whatever. Over here are distances. They give you the mass, they give you the diameter. And they have all the labs done out for you. Not done out, but like the questions done out. And there's a stopwatch, so you can time things, you can measure things, but it's kind of a, like if you've ever done direct measurement videos, it's sort of like that as well. So I think that's all I have for the cheap stuff. Let me go through my notes. Sorry, guys. Yes. Good. Did anyone have questions on that? I'm going to share file. And I'm just going to put this in the, it's taking forever, of course, I don't know why. Share. Copy link. Sorry. So this right here, what I just put in is the PowerPoint that I used tonight. So if you want that, if it's not working, someone just raise your hand and let me know. I'll adjust the settings. And then the other thing I wanted to share with you all is this. Share. or copy link. Did anyone try the thing I just put it, the PowerPoint? Did it work? Could you open it? Yeah, okay, all right. And then here is my drive. Can you open that? Someone besides Susanna, because I know she checked it already. Thomas, you can open that drive? Yeah, okay. So I'm going to share just for a second. This is kind of all the stuff I've basically been talking about for this. You will actually have, and you're welcome to use. So I've got direct measurement videos, labs in general, LL diagrams, practice exams. So if you want PDFs of those, all of the tipper ranking tasks are already here. You can copy and paste them. Then I have it unit by unit. So like if you look at kinematics, I don't know why it goes twice, but alas, it does. And then I've got labs. I've got a sample quiz. I use Check for Understandings. You can steal that. Packets. So at the beginning of a test, at the beginning of every unit, I give them a packet. So if you're looking for tips on pacing, you probably go to the packet part in any unit that you're thinking about. And it will tell you what I'm going to go over. That's their homework, but it kind of gives you how many days I spend on every unit. Just to give you an idea, if you're trying to pace with what you have, we have every time there's a period listed on there, it's 54 minutes for me. And if it's double lab, that means I have two 54-minute periods. So if you're looking at that and trying to scale what that means for you, then that's that. All right, so we have 5 minutes left. So I guess I'll just leave the 5 minutes for any lasting questions that you have.
2 hours went pretty fast.
I know, I'm sorry, I talk fast. Hopefully you learned something. If nothing else, you have lots of labs to steal from and sample tests. I actually, for all my assessments, I only give sample AP exams. So at the end of every single unit, they have what I call a quiz, which is 12 multiple choice questions. And then the next day they have their test part, which is the 3 free responses that they have to do. So all my assessments are based on the AP exam because I just want them to get used to how they are worded and such.
So you do everything on paper? So you hand the printed?
For tests, I do, yeah. Okay. I still do that. I probably, towards the end of this year, actually probably sooner than later, I'll have them do it online, the multiple choice online, because they do need to do that for the real AP exam. So I probably should get them used to that.
And how do you give feedback? Or do you go over the questions as a class, or?
So I give feedback for the multiple choice. I just tell them right answer and they come in if they want to for extra help. I also allow makeups for the free responses. So if they want to do makeup, I make a new question that's similar to the one I've already given, and they have to come in during a free period or after school and take the one that's similar, and they can get half their points back. I used to be like sort of against makeups, but then my friend convinced me to try it, and my AP scores like definitely went up because they saw the topics again, like they actually understood it instead of getting a bad grade and be like, oh well. So they actually come back and try to learn it a little bit. Did anyone else have any other questions? You have paid your dues. If you would like to leave 3 minutes early, you're more than welcome to, or if you want to stay because you have a question, feel free to do that. So you will get, I will, hopefully in the next 2 days, I really got to finish my college recommendations, but hopefully in the next 2 days, I will get back to your assignments that you posted and I'll have a little bit of feedback, but don't forget that you're welcome to email if you want anytime throughout the year. I'll be happy to help, or if you look at something in the drive and you don't really understand it, feel free to send me an email. I'm happy to help.
was curious, like, I understand, like, you give packages in the beginning of each unit. That's what you said, or?
Yeah, that where if you look at the unit and I say packet, I at the beginning of every unit I give them that packet so that they know when the test is going to be. I mean, obviously, I'll move a test if later if I'm realizing they don't understand or we need another review day, but they basically know when everything is going to be.
Okay.
Yeah. Anyone else have questions? And thank you very much for coming. Hopefully you were able to get something out of it. And I
Really
appreciate
quick, Kim.
Yeah.
I looked at I opened up the PowerPoint that you shared, and some
Uh-huh.
of the links do not, the request access.
So
It looks like some of them I could open, but some I couldn't. So
the links might not all work, but everything that is in it is in the drive. Yeah.
Okay.
Yeah.
Okay.
So like look, I guess like in the search bar in the drive, whatever it says, try to look that up. And if
Okay.
you still can't
Okay.
find it, send me an email and I'll figure it out.
Okay. I didn't know if I went to the drive if it would also have request access.
So I
I didn't know if that.
think the drive is working.
Okay.
I had someone test it for me, but they obviously didn't test every single link. So
Right.
feel free to, if there's a link in the drive that isn't working, let me, send me the request or whatever.
Okay.
Yeah.
Okay. Okay. Sounds good. Thank
And I
you.
made you all viewers, not editors. So if you want to edit, you'll have to, make a copy and then do it from there, just so that everyone has like the same initial access to it.
Yeah. 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 Can we copy that whole folder
So what?
at one time, or do you have to do individual? Like, if
So
we're
I
gonna
tried to, that's
have to
how
do
I made that folder. What I did was my easiest way to do it was I downloaded it to my computer, and then it doesn't really let you copy a full folder.
Right.
So I like downloaded things in separate pieces and then re-uploaded them to the Google Drive.
Yeah. Okay. Okay. Sounds good.
Quick question.
Yep.
Just off the top of your head, whatever you can remember, I regretted not writing down. You went through AP Classroom and told us like the things they wanted, us to know, but then also your favorite resources on there, and one of them was the AP Teachers Chat.
Yeah.
What
It's called
What were some of the others?
Oh, the AP community, and then I use really I just use the question bank.
Mm-hmm.
And then I also I don't do it as much anymore, but when I was first like designing lessons and stuff, I just would print out the unit plan and like look, or I guess it's not unit plan, but like unit description. And I would just make sure I'm covering everything that was on there. Plus they also give you activities too.
Okay. I think that is what I was trying to think of.
Okay. Yeah. It just helped me plan like what I specifically had to teach for that.
Great.
Thank you, Kim, for your workshop. Can I ask a question, please?
Yes. Oh, wait, yes, do you have a question?
I'm a kind of learner, and I never taught AP, but I'm learning the steps, and I want to attend all the workshops in order to, for example, to get in the AP community. My question is, do you receive participation certificates after the workshops, or?
Yeah, so when we like finish this I think within 24 hours you'll get a like a survey, and then once you fill out the survey, then you'll get like some kind of participation thing of some sort.
Okay. Thank you very much, Ken.
You're welcome. Have a good night.
Thank you. Take care.
Thank you very much. Feel free to take off if you need to. Did someone had a question?
Thank you, Kim. Appreciate it. Thank you.
You're welcome. Feel free to reach out if you need anything.
Okay. Sounds good. Thank you.
Thank you. Oh, for a new, just in general, do you mean for suggestion for a new AP teacher? I would say work on your planning and do as many labs and activities that you can do. Like really focus everything on labs. And also if you're like feel like you need to learn more, they College Board or ETS, I don't know what it is technically, runs these things called APSIs, which is a whole week. It's called it's like a summer institute. I'm gonna put a link in here for you. Hold on. Nope, we don't want that. All right, so I'm gonna control copy. If you feel like you need here. So this link right here is to what we call APSIs. They're 4-day workshops. And it would be even like more focused and just like a ton more information. It'll be like 8 times 4, 32 hours of instruction on AP. So if you're like really nervous, I recommend like trying to go to one of those.